Okay, thank you, Rachel, for that warm introduction, and I'm especially pleased to hear that I helped you get involved with CHI. That's great. So for most of my career, I've kind of felt like I've been in between the fields of HCI and AI. So how many of you consider yourselves HCI people? Okay. How many people consider yourselves AI people? A few, okay. And how many of you consider yourself skeptical about AI? Don't be shy, I won't kill you. Okay. All right, okay. So I've always felt like I've been in between these fields, and I want to think a little bit about the relationship between them. So in some sense, I think that they're both trying to do the same thing. Okay. The goal is to make computers more useful to people and to make computers easy to use. Everybody agree with that? Okay, good. Okay. But the problem is how? Okay. The AI people will tell you, oh, the reason computers are difficult to use and they're not any good is because they can't do representation, they can't do reasoning, they don't understand what the things about the world. So AI people will tell you it's an AI problem. Okay. Whereas if you go to CHI and you ask them what's the problem, they'll tell you that, well, you know, we just don't have really good direct manipulation interfaces, and we need more and better user studies, and we need better design, and so forth. And they often, AI and HCI people get often in these knockdown, drag-out arguments as to which is the best way to approach this goal that hopefully everybody shares. Okay. In the past, HCI has been, now I think there's a little bit more kind of skepticism on the HCI side than on the AI side. So here's an article by Ben Schneiderman called The Limits of Speech Recognition. And here he says, human-human relationships are rarely a good model for designing effective user interfaces. Okay. Well, to an AI person, them's fighting words. Okay. You know, to say that speech recognition, you know, shouldn't be used for computers, I mean, to me, that's astonishing. You know, we talk to people, we get a lot done that way. Why shouldn't we be able to talk to a computer? You know, so, and there's been a lot of thread of skepticism about AI in HCI. So people worry that AI, so you'll have to say things 5 or 6 times before the computer understands you for speech recognition. Or it might misunderstand you in some terrible way. Okay? Or we've all seen the science fiction movies where the robots take over the world, or, you know, and people get scared about that kind of scenario. Right? So this has caused a lot of people, or then HCI people might feel like, well, just the problem's too hard, so let's solve problems that we can solve. You know? So there's been a lot of skepticism about AI from the HCI community, and one thing I'd like to do is defuse that a little bit. Okay, they're not without some reason, you know. So because there've been some spectacular failures and flameouts of AI over the years, and the one that everybody really loves to bash is the Microsoft paperclip. There's a long story behind that. Huh? We're at Microsoft. Any Microsoft people in the room? I think in some ways it wasn't so bad, but in some ways it was pretty bad, and so that's kind of the poster child for misapplication of AI in some sense. But on the other hand, there have been a lot of interface successes in AI, and not all of them have been recognized. So I just picked a few that, you know, I use personally or that I think. So, you know, I have an iRobot in my house and it cleans the floor, and boy, that's great. You know, I love it. Okay. Amazon, you know, when I log into Amazon, it says, here are some things that you recognized. Okay. Here are some things that I'm using collaborative filtering to recommend for you. Okay. That's sometimes helpful. Sometimes it's not, but hey, sometimes it works. Okay. I have a GPS in my car that uses speech recognition. So after all, Ben Schneiderman's complaining about speech recognition. I have the latest speech recognition GPS in my car. My car is old enough to vote, so it's pretty noisy. Okay, and yet the speech recognition works just fine, and I love it. So, you know, the track point, the little pointing device, on the IBM and other kinds of laptops actually uses an AI model to try to predict where you're going to go next, and that's essential for its success. Mark Nabedian is in the audience from ITA, so that, it does an intelligent search on finding plane flights. I use that all the time. Even things like Google, I think, are, it uses a lot of natural language techniques that were originally developed for general natural language understanding. It's not trying to do that, but it's using a lot of those natural language techniques, so I would claim that's a success of AI too. There are a lot of behind-the-scenes successes of AI. So American Express uses AI to approve purchases on the credit card. Okay? And there are lots and lots of stories about this. So I think AI has actually achieved a lot over the years, and I think HCI should recognize that more. On the other hand, so that was the skepticism from the HCI side. Okay. On the other hand, AI has pretty much just ignored HCI. AI has ignored HCI. So here's the latest issue of the AI journal, okay? And you get articles like defeasible inheritance with Dowd index and its axiomatic characterization, okay? And, not that this isn't an important problem, but if AI is supposed to be helping people, then how come we don't have anything about, people in there? Okay, so AI the field has kind of gotten sidetracked off on all this mathematics, and while it's useful, we need to come back to the problems that people have. And I think AI has gotten too focused on the 100-year goals of intelligent robots. And even though AI has made a lot of progress, the software that we use every day is still as stupid as it used to be. Okay, so I think there's a lot of room for us to use AI in just all the everyday software that we have. And I don't think AI as a field is focused on that. So AI as a field says we're going to solve these very difficult mathematical problems about reasoning, and we'll leave the interface till later. Okay, and everybody knows what happens when you leave the interface till later. Okay, and there have been a number of very high-profile AI projects where, and we'll talk about this maybe a little bit later if we have time, where the AI guys just got in and they put some predictive algorithm in it, and then the users hated it. Okay, and it wasn't until they understood the HCI issues that the project then became successful. Okay, so AI and HCI have this love-hate relationship. Okay, so the skeptics about AI, they say, hey, where are all these intelligent machines that you've been promising us all these years? Okay, and I think that's a fair question, okay, but you have to keep in mind it's a long-term goal, that having a fully intelligent machine is a long-term goal. There can be a lot of steps along the way, okay. Now, HCI is living in a glass house, right, because you could just as easily ask, well, you keep telling us that there are going to be these easy-to-use interfaces that are going to meet our needs, but then when I look at what's on a computer today, it's not that. I have to learn all this arcane crap, in order to, I have to use these applications, I have to remember file names. What's that all about? That doesn't have anything. I just want to plan a trip or balance the budget. Why do I have to understand about file names? Okay, so HCI also has to answer for why it hasn't accomplished these goals. And I think also we have to have some patience in both of these things. So these are long-term goals. We have to, take a lot of steps along the way. But I think it's most important to realize we're both on the same team with this stuff. So why should HCI pay attention to AI? And I think that the current path of human-computer interface is not sustainable, okay, for a very simple reason. So if you have a conventional user interface, okay, most our conventional user interfaces are based on things like icons and menus and commands and selections and dialog boxes, okay? And basically what all those things have in common is there's a one-to-one correspondence between the functionality and the control, okay? That's how you build a usable interface. If you say, I see a few controls, each control does a thing which I understand, and if I want that thing done, then I use that control. Okay. But the problem with that is, as the number of things you want to do goes up, the number of controls goes up too. And we can't keep that going. Okay, so how many applications are you going to have on your machine? How many commands is each application going to have? How many buttons are you going to have on your phone? Right? There's going to be a limit. And if we want things to do that, computers to do things that are past that limit, we've got to get beyond the one-to-one correspondence. Okay, so that's the job for AI. Okay, now there are two phenomena that I like to talk about, which AI people know very well, but maybe you're not so familiar in the HCI community. One is called the small size of infinity, and one is called disappearing AI. How many have heard those terms? No, hardly anybody. Okay, so let me explain them. So the small size of the infinity is this. When you think about some very, very hard AI problem like natural language or speech understanding or collecting world knowledge about a subject, you think, oh my God, it's there's an infinite number of ways to say something, or there are an infinite number of accents that people have that a speech recognizer might have to do with it, or if you want to solve a problem, if you want to do music recommendation, there are an infinite number of tastes that people could have in music. So, well, it turns out there's not an infinite number of any of those things. Okay, there's just a very large number. Okay, and what we find time and time again is the infinity isn't as large as you think it is. Okay, and as Moore's law goes up, then very often these large numbers become feasible. So that's why we're seeing success now of things like speech recognition, where we can just make very, very large models of the relationship between phonemes and audio. Okay, and some of those, we can store these large things. We can search them very fast, and so we're able to solve problems in some ways that we couldn't before. Okay, disappearing AI is this phenomena that once AI becomes successful, the success disappears. It doesn't become part of AI. AI is not credited in. It becomes just part of the general society. Okay, so for example, you won't find a Roomba in the AI section of the department store. Okay, it's in the home appliance section of the department store because that's what it does. So sometimes people have trouble recognizing that that's a success of AI. Okay, so how do we get these communities together? And I think that what often happens when HCI people approach AI is they say, oh, these AI people, they're barbarians because they don't know about how to design good interfaces. And we're going to get on our white knight and show them how to do user-centered design and white horse, and show them how to do user-centered design and do it right. Okay, and that's true. Okay, because there has been a history of projects where the AI projects have lousy UI. Okay, and they have great theoretical performance, but then you put them in front of users and they suck. Okay, so then we need to educate AI people. You need to educate AI people about the importance of user-centered design. So you have to study users to find out what they really need. You have to understand their work practices deeply, and then maybe you can make better interfaces with them. Okay. At the same time, we have to realize that the kind of HCI methods that are good for just making a website for the fire department, might not be so effective when they're brought to AI problems. And so, for example, you want to do some user test, and you just do some small test of one interface versus another interface, right? But an AI interface, you need to have a long-term relationship with it. It has to learn about you. So you may need to do tests that extend over a longer period of time. Okay. Some of you know that I'm famous in the HCI community for an essay called The Tyranny of Evaluation, where I pointed out that a lot of the HCI evaluation methodologies make a lot of assumptions that aren't true for all kinds of interfaces. And so I think HCI people need to seriously look at what in their methodology needs to change when you start to deal with AI interfaces. And I think if they do so, then that can be very effective. So that's the HCI people. So now when the AI people approach HCI, they get on their white horse, and they claim that they're going to civilize these savage HCI people, okay? And what they think is that the HCI people don't want to deal with the meaning of the applications they have. Yeah, you can push bits around the screen, and yeah, you can have menus, and you can have icons, but ultimately, if the system doesn't know I'm planning a trip, how can it help me plan a trip? Okay. The systems don't have any world knowledge. Okay. So, yeah, you can do direct manipulation, and that's great if the thing you're manipulating is exactly what you want, but sometimes it degenerates into what I call target practice. So you say, okay, where's the operation I want? Oh, is it on that menu? Oh, yeah. Okay, I got it. Okay. So, things can degenerate into target practice. You do tedious, repetitive operations to get stuff done. Okay, take this file, copy it here. Take this file, copy it here. Take this file, copy it here. Why can't the thing just learn that I'm trying to do that and just be done with it? Okay. And I think that we have to get past, in the HCI community, this fear of AI failures. So AI, it can succeed and fail. It needs to be tested. It needs to be improved, and so forth. But you can't take the position that, oh, because the problem is hard, we're going to run away from it. Okay. So if you have AI and interactive applications, I think one of the biggest things to get us out of this dilemma of too many controls and too many functions for too few controls, I think is to think about goals. So the user has a goal. The user wants to plan a trip, or the user wants to buy a car, or the user wants to record a song and then put it on their web page. Okay, so those are things that the users want to do, but the problem is the system can't recognize that intent. Okay, so the system doesn't have goals. The system typically has functions, so it has concrete actions in the software that the software can do, and right now we're relying on the person to make that mapping between what the person wants and what the software can do. And more, I think what we're going to do is put that burden on the machine. Okay? So then the system can anticipate what the user is most likely to do. It can make the most, and it doesn't have to completely replace the direct manipulation interface. It can just modify it in some way, or it can make the most likely thing easiest to do, or it can remove steps that would otherwise have to be taken in the interface. Okay? You don't have to solve the whole AI problem. So people don't appreciate the extent to which almost all interfaces that we use now are under-constrained, in the sense that they reach a point where they don't know what to do. If you say open a file on the machine, which file? I don't know. Could be any file, right? Okay. So what you want to do is just put a little bit of knowledge. So instead of just open any file, you want to say, what was the user working on last? What might they be interested in? Is there anything related to what they're doing? Can I anticipate what file they might want next? Okay, and so sometimes so if you look for these situations where a little bit of knowledge is better than nothing. Okay, sometimes a little bit of knowledge is a dangerous thing, but sometimes a little bit of knowledge is better than nothing. Okay, and also when you have a little bit of knowledge about a lot of things, it can be more useful than have just a lot of knowledge about something very specific. And AI gets you that broad knowledge. And you want to look for cases to use AI in the interface that are fail-soft. So I wouldn't recommend the use of AI for nuclear power plants and air traffic control and things like that. But on the other hand, if it's just saving you a few minutes during your daily life, then if you make a mistake, it's not that bad. Or if Amazon recommends you a product you don't want, hey, it's not that bad. So I think what we should do is look for these fail-soft applications areas of AI. So I'll just run through a little. So here are some just statements of CHI, what I call political correctness. So this is sort of what CHI people say we should be doing with our systems. We should help users accomplish goals. We should support users' work practices. We should accept input in natural ways. We should encourage collaboration. So nobody at CHI would argue with that, right? Okay. So let's just look at how AI systems would fit into these goals. So again, AI can have recognition of goals, plans, intentions. Okay, it can help you generate plans, and it can do adaptation to user goals. So we worked on a an interface called ROADI for consumer electronics interfaces, which does recognition of plans and uses common sense knowledge to figure out what your goals are. So if you say, I want to watch the news, no button on your stereo says play the news, okay? But you could figure out that maybe there are stations that do, and what's the number of that station on the cable channel, and then tune the television to that station. Okay. They should be sensitive. So a lot of people at CHI think a lot about user context, but what is that context? Okay. And in AI, there's been a lot of work in modeling context explicitly. So we can say, what does it mean to have context? And we can get the system to react to that context in real time, rather than just have it through the intermediary of you have some designer look at it and then they redesign the system, and then next time it'll be better adapted to the context. In HCI, there are things like GOMS and keystroke model, where they're trying to look at efficiency of input. So in general, an interface is better if you can do just a few things and get more accomplished that way. So there are various ways of modeling the kind of efficiency of input in HCI systems. If you have to go through too many web screens to get to something, it's not good. Okay. So you could think of AI as being an amplifier for the user input. So if the user says a high-level goal and the system can implement it directly, then it doesn't have to go through all the input steps that would be necessary to do that. So I think we can, and right now I think in the direct manipulation, applications, icon, menu systems, there are just too many steps that you have to go through to get even the simplest things done. So I think we could streamline a lot of that and just get a lot of that out of the way. And then, of course, things like natural language, speech recognition, vision, gesture recognition, those will have much more natural and much more efficient ways of interacting with users. Now, these problems are very hard. Okay, we don't claim to have solved the natural language problem, but what happens is people made a lot of claims for this stuff early on. They said we were going to solve natural language, we were going to solve speech, and then years went by and it didn't happen. Okay, and so people got discouraged. So after a while, you kind of think, oh, it didn't work, it didn't work, it didn't work. Oh, it'll never work. Okay, but the problem is, in AI, 10, 15, 20 years go by, and then nobody asks the question, well, it didn't work then, but does it work now? Okay, and so these things like speech recognition and natural language understanding, statistical natural language understanding, they kind of make steady progress over the years, and so the progress is kind of slow. It never meets the HCI criteria of, setting some very high bar like 100% word rate speech recognition. But it just gets better and better, and I think it's time now to really look at all this stuff again and say, yeah, we thought it might not work, but maybe now it does. Okay. If it doesn't, then we have to just go to sleep again for another 10 years and try again then. But we have to make sure. Yeah, question.
Question. Kind of several things you said seem to kind of go after that. Often people prefer predictable, but very simple interactions that are kind of smart but unpredictable.
Right. Yeah. So, that's true. So one of the things Ben Schneiderman says, what is it? Simple, predictable, controllable. Okay. And that's good. But the problem is it's only good for when the thing you want to do is also simple. So if I say, if I got an iPod and all I want to do is play music, and I say play music, I hit the button that says play music, that's great. Okay. But if I want to do a million different things, then I can't have a million controls. Okay, so I think rather than just say simple is better, or I say, okay, instead of having a phone that does everything, I'll just have a phone that makes phone calls, and then I'll, get another device to do something else. Okay, but then the problem is your pocket fills up with devices. Okay, so it doesn't make the problem go away; it just slices it in a different way. So I think simple things are good for everything should be as simple as possible, but no simpler. Okay? But I think we're moving into an area where we want computers to do more and more complex things. And in fact, we're already in that area. And so the question is not whether we're going to stop at doing the simple things, is it how are we going to handle the more complex things? Yes?
Simple comment. You just said that whatever AI theories and algorithms were created 20 years back, now your retesting is working. That has a lot to do with the fact that the processing power has also
Yes.
tremendously. And so the response to whatever you are doing is much more real time than 20 years back.
That's right. That, absolutely, yes. So, you know, another big thing is CSCW, and I think that one thing that AI has learned from what we call mixed initiative interfaces is kind of collaboration between people and machines. And so I think there can be a branch of CSCW where one of the collaborators isn't a human but a machine. Okay, and some of the principles of CSCW, can also be applied. So I think that's, so two heads are better than one, even if one of them is a machine. Okay, so I think that, and I think CSCW as a field has ignored that as a possibility, hasn't really come to grips with that so much. And I think, we make a big deal in design about having things be culturally sensitive, and I think that's true. And there's a whole activity of internationalizing things so that they become sensitive to cultural differences. But I think, but in AI, and we look forward to the future when language translation is going to be one of these problems which essentially will be solved, and also that you can have AI programs that understand what the cultural context is and adapt on the fly. And we're doing some of that work in my lab. I don't have time to talk about it all, but maybe we'll return to it if you're interested. We certainly need better ways to integrate AI with conventional operating systems and applications. Programming languages are a real problem. They're not, and the applications are typically designed to take over the computer. So they're not designed so that some other entity, some other piece of software can be watching what you do or affecting the interface at the same time. So the problem we run into when we're programming all these software agents is the interfaces won't play nicely with others. They expect that the interface is just going to take over the machine. You're going to be interacting directly with that interface and nothing else. And then if you want to do anything else, you've got to switch applications. But that's kind of death for us because we want to still be in there in the application. We want to still understand everything you're doing and then also be able to provide you the help or other things that we're going to do with the AI. So I think we need to think about on both sides of how to integrate AI with HCI on the software level. So I want to maybe just take a little time and talk about my own work, okay, just to give you a little flavor of it. And one of the things that I'm working along with Karthik, one of my students here in the audience, is common sense knowledge. And I think this is a perfect example of one of these small infinity problems. So how much common sense does it, so let's talk about common sense knowledge as being things like use a clock to tell time, or you use shoes on your feet, or you sit in a chair. How many things like that does a person know? Is it 1,000, 1,000,000, 1,000,000,000, 1,000,000,000,000? What? Anybody got any idea? Estimate? 1 trillion? Okay. 1,000? No, come on. It depends on the person, yes. Yeah?
I guess around 100 million, guessing that people know about maybe 100,000 objects and might know 1,000 things about each object.
Good. 100 million is actually a very, very good guess. Okay. Here's one way we can get at that. So a person lives for 3 billion seconds. Okay, I'm sorry, but that's all you got. Okay. All right. And, if you learn the thing a second, well, gee, that would be a lot, okay? So probably you can't learn that much, okay? And you know most of the common sense knowledge by the time you're 12, okay? And let's say you learn 2 things a minute. That would be a lot. then you'd know 100 million things. So that's why it's a pretty good guess. Now that's probably a high number. Huh? What?
That's why I say a million, because probably forget 90%.
Yeah, okay.
One end of life.
Yeah, all right, so, but that's good news. 100 million things, that's good news, because today's computers could easily store that, you know. Yes?
I would say you can infer much more.
Yes, good point. You can infer much more. But the problem is, every time you do one of those inferences, you've used up one of those seconds. So it doesn't increase, you know, or you've used up a half a second, right? So you won't get much beyond that 100 million that way, yeah.
Would that depend how complex the society is that you're living in?
Maybe, but we're just talking back of the envelope here, yeah.
Does it really include things like geospatial knowledge?
Maybe not, but I said just the knowledge that you can express in sentences. Okay, anyway, so what we did was we set up a website and we asked people to type in common sense knowledge. Okay, and it's called Open Mind Common Sense. There are some examples of it you see on the right there. Taking final exams is for passing a class. A dish could be broken. You know, so here's some knowledge about fruit, and it's asking you some questions and so forth. So right now we have about 1 million statements in English. So we have roughly 1% of a person's common sense knowledge. Okay. We have 2.7 million in Chinese, and we have a number of other languages, and that's where we're doing some work in translation and cultural things. So we use a natural language parser. Yeah.
Sorry to interrupt, but if I say such a thing such as, if I hit my head against the window, it hurts, but then I can say the same for a million things, right?
Right.
So can I just say, well, I know a million things?
Yeah.
I would say it works with
All right, well, good question. Okay, and there's a balance between, you know, doing everything explicitly and, you know, saying one thing. But what we did was, so, and I don't, you know, it's a much bigger question. But what we do is we just ask people for common sense knowledge, and we think we get a pretty good sample of what people talk about. So if people say, I bang my head against the wall and it hurts, then we know something about banging their head against the wall. And then we do have some inference which can expand it out, and I'll talk about what that is in a moment. Okay, so we create something called ConceptNet, which is a semantic net. Some of you are familiar with that idea. So here's knowledge about breakfast. You wake up in the morning and then you eat breakfast, and the effect is a full stomach. Okay, and it's connected to a lot of other things that maybe you might do or might know about. Okay, so that's ConceptNet. And then we have a special inference procedure for it called analogy space, and this is sort of where the trick comes in. What we do is put all that knowledge into a box, okay? And we can arrange that box along various dimensions, okay? So one dimension that we arrange it along is what's good and what's bad, okay? So banging your head against the wall is probably bad, right? Because it hurts and people don't like getting hurt, okay? So hurt causes pain. People don't like pain. Okay, so we can classify the concepts that we have and the statements about the concepts by putting them into this big box and doing a very rough kind of reasoning on it. Okay, so you know, for those of you who get interested, I can explain the reasoning, but we can't say what it does is gives you a very rough way of just understanding what's similar to what the context of things is, whether things are good or bad, or happy or sad, or urban versus rural, or cheap versus expensive. You can make those kind of very rough judgments with what we have. Okay, so that's the basic technology. How would you use that in interfaces? Okay, we have a whole bunch of projects which I can't talk about, but so you know, one of the things that I'm very interested in is storytelling with media. So we're taking all this media on our phones and all our cameras and video, and how do we organize it and use it to tell stories? We're consumer electronics stuff. We're trying to untangle all the crazy push and hold buttons and all the other crazy stuff that happens in consumer electronics interfaces. We're doing some work in making programming easier, code sharing and reuse. We're making tools for understanding, to-do lists, calendars, personal information management, things like that. So we have a very wide range of HCI application projects that we have with this, which I invite you to go see on our website. And we're doing large-scale natural language analysis and things like for opinion mining. So what we found is basically that this common sense knowledge and the AI reasoning techniques that we're using are kind of a gold mine for human-computer interface, because they allow you to have some idea of what's reasonable or what a user would want or what a user might expect or what a user might do next in some situation, where otherwise you just have to show the user a huge list of possibilities. So being a Media Lab person, I can't do a talk without any kind of demo in it. So I'm going to show you a demo of a system called Raconteur. And Raconteur is a kind of a chat system, and it's trying to deal with this problem that, okay, we take thousands of photos on our cameras and phones and computers, and what is the use of all this media? Very often it's for storytelling. What you want to do is tell a story to somebody else, okay? You want to tell them about your trip, or you want to tell them about something about your family, or you're in a corporate environment and you want to tell the story of the product so that consumers understand it, or investors will invest in the company. So a lot of the use of this media is storytelling in one way or another. What we want to do is make an assistant to help you to help the system understand what the user is trying to say about the media, and then automatically help you retrieve media that that are useful for illustrating what you want to say without doing just things like keyword matching and having the words be the same or having things be tagged and so forth. So I'll just show you a brief demo of this system, Raconteur. And this was the thesis of a student of mine, Peggy Chi, and it'll be presented at the IUI, the Intelligent User Interfaces Conference in February. Okay, so what we have here is a chat system. So, oops, let me get back to the beginning. So what we have here is a chat system, and this is your personal photo collection. Okay, you say, my trip to Spain was full of surprising experiences. Okay, so what we do is we actually try to analyze the natural language, and we say, what's a surprising experience? Okay, so so common sense tells you what isn't surprising. So you can say something is surprising if it is not exactly what you would expect from the common sense. And we can go into our common sense knowledge, and we can ask the general question of what's common or what's surprising. Okay, so we have, and what we assume is that at least some of these photos or videos are tagged with just a sentence or two that describes what it is. So it says, you know where this is? This is a police office. The first time I had to visit a place in my life, I lost my wallet. Okay, so you're talking about this trip to Spain, but then you have a picture of a police office. Okay, so the system identifies that as being something surprising, and it's connected through this episode of you lost your wallet. Okay, and then there are some other possibilities. Okay, so here we have we drag the picture of the police office. Okay, and then we drag another picture that says, we were headed to the museum and we're not aware of anything special in this town, but this art suddenly appeared in the park. So they were just going to this normal city park, and there was this huge installation, which was a piece by Dali there. So we're able to recognize that that's a part where something unusual may have happened. Okay, and it turns out the person we're chatting with is a big fan of Dali. So it says, art from Dali, you went to the famous museum. Okay, we type a reply to that, and that brings up again more pictures about the city where Dali was born. This is the anamorphic sculpture by Dali there. Okay, and then it says, have you seen the picture of this face before? Okay, and this isn't just a face, but this is a special piece by Dali that was in the museum. Oops. Okay, I think so, but what's so special about it? And then when you, this is one of these things where you get to see the piece through a small window, and then when you actually walk in the room, you see it's just pieces of furniture that are aligned to make the face. Okay. So what I want to show here is what we're doing is we're making an assistant to help you retrieve media during a chat, okay? But we're trying to go a little bit deeper than just keyword matching. We're really trying to understand, what kinds of patterns are there in stories that would help you explain the story, help to provide an interesting experience for the listener. Okay, and to try to help people interact more. And we're also interested maybe in the future of being able to have some kind of thing on phones, where you don't have much screen space for browsing all your pictures, and you'd be able to just be, chatting, and media would come up very quickly, and you could create a kind of interaction that's somewhere between just an ordinary text chat and some more, authored media, like I want to make a website about my trip, where I carefully construct the story in advance. Yes?
So that looks to me, like a typical AI system.
Okay.
So what would happen if
I don't know if that's a compliment or an insult.
No, it's just, I like both.
Okay.
So what would happen if you would start now designing it with HCI in mind? And have you thought about it, how the whole interface would change?
Well, I think, first of all, Peggy might be disappointed to hear that you didn't think this one was designed with HCI in mind. But I'm sure there are a lot of ways we could improve it, yeah. So we haven't really done much, user testing on this. We did a little user testing, which is reported in the paper, but I think there's probably a lot of ways in which we could, improve it by really understanding, the needs of users, or maybe there might be different groups of users who would have different needs in such a system. So we've thought about both, kind of amateur scenarios like this, where you're just talking about my trip, and then also maybe a more professional system where you have script writers talking about, an authored story and trying to decide between different versions of it and that kind of thing. More questions about this? Okay, all right, well, so I just wanted to, just give you a little sample of what it would actually look like to put some non-trivial AI, to put this common sense knowledge into a interactive system. And I think this kind of thing is where we need to go in the future. Okay, so I'll just finish up, and I think what we should do, to encourage HCI people to consider AI solutions, I think, first of all, we have to celebrate our successes. So, we have to get out of this disappearing AI thing, and we have to recognize that already AI has had a huge impact on many interfaces. And then I think one thing that encouraging trend that's happening is now some of the AI algorithms and the AI techniques are getting mature enough so that people package them up so that they're easy to use for HCI developers. If any of you are interested in the common sense knowledge base, we package that up into an open source system called the VC. And if you just search for that, you'll find that, and it'll make the common sense knowledge base and our reasoning methods available if you want to try your hand at putting a little bit more intelligence into some of your systems. Weka is a open source machine learning program toolkit that has a lot of the recent statistical AI learning algorithms in it. There was actually a paper in CHI 2 years ago, I believe, from James Fogarty, where they talked about, just from the HCI standpoint, what the developer's experience is in integrating machine learning into their thing. And I thought that was kind of an interesting article because it bridged that gap. And I think, as I've done here, is to point out how AI techniques can meet the goals that HCI people have for their systems. One of the things, I'm now speaking to the HCI community, but there's been a group of us that have gone back and forth between these HCI and AI communities trying to broker a truce, as it were. And to the AI community, we recently had an issue called Usable AI, an issue of AI Magazine, which you'll find the essay. I wrote an essay with the same title as tonight's talk, and that can be a little souvenir of the talk if you want to read that essay. It's also available on my webpage. And there's a number of interesting articles by Tony Jameson, Aaron Spalding, Tessa Lau, and a lot of people who have both talked about what are the HCI problems for AI systems, and also how can AI improve HCI in a lot of these systems. And so this is more speaking to the AI community rather than speaking to the HCI community, but I think there's a lot of interesting stuff in there. And finally, I'd like to put in a plug for the IUI Conference, Intelligent User Interfaces, which I think is the conference that, I mean, I like CHI, I go to CHI, but the IUI community is I think, the place where the community of people who are both interested in AI and HCI come together. There's also, I should have put a thing, there's also a new ACM journal called TIIS, Transactions on Intelligent Interactive Systems. And so that's a venue for journal articles that try to achieve a synthesis of AI and HCI. So I'd encourage you to look at that. So for this AI versus HCI debate, I say peace. Thank you. Okay, questions? Yeah.
I was wondering, how do you see the future of the duality, I would say, between systems that are just meant for you, that learn what you are doing as an individual and that adapt to you, versus something that is global and learns from everybody to infer something common? What is it might be very noisy if you think at a large scale, but on the other hand, it shows that we also infer very interesting things.
Yeah, good question. So the question is, what about systems that just learn from you versus systems that learn from everybody in kind of a crowdsourcing manner? And I think that we need both. And I think the thing is that even when they're learning from you, okay, so one of the things about the traditional statistical machine learning technique is they take a lot of examples. So there's what we call the cold start problem. So you have to have thousands of examples to train up a machine learning algorithm sometimes, right? But a user isn't going to sit there and give it 1,000 examples. So the user wants it to do intelligent things after 3 or 4 examples, right? So maybe you want to collect, crowdsource and use that as the default. If you don't know anything specific about a person, then you use the crowdsource defaults.
But when you do that, my point is from a final user perspective. When you do that, you might end up having something that is too generic to be useful for you.
Yeah, that's right. So maybe the interface has to change over time. So as you use it, it gets more adapted to you. And so typically, if you have a new assistant on the job, a new secretary, something, they make some assumptions about what it is you might want, but they don't know you. But as over time, they get to know you better, and then they can be a lot more helpful. So I think, whereas in most conventional HCI systems, it's the first time you come up to it, it never learns from you, and it's the same every time you use it. So, I think we have to get away from that. Yeah.
The system that you showed, there is a lot of dependence on having some kind of tags or context to each photo, right? But do you think that devices out there make it easy for people to just add that kind of context? Because lacking that context, no matter how good the AI algorithm is, it's not going to be really powerful because can't find the photos.
Yeah.
And some of it is there, like geotags, and some of that is there. But say museum, you're not just going to infer museum from a geotag unless there's another layer which says, oh, there's a museum nearby this tag.
Yeah. All right. So so in our system, the sentences that you saw there, it's optional, so you don't have to put them on everything. Okay. Some of it is also learned from the user interaction. So if you pick up a photo and then put it in one of those spots, then the things that are you said get tagged to that. Okay. So that's another thing that you can do. Geotagging is a good idea. And then what's happening now in vision is there are some algorithms, and they now appear on consumer cameras, that can tell you things like how many people are in a scene. They can count, the red eye, there's red eye correction and things like that. So, it can tell you whether it's an indoor scene or an outdoor scene. Okay, we could, if you take a picture that says Guggenheim Museum in New York, then maybe we could even read the characters off of that photo, using OCR. So we, geolocation, so any source of information that we can get about what the context of that is, or what it might mean to you, or we can match it to other photos that other people have, or, there's a lot of ways we could get this metadata. But the idea is that if you have a lot of rich metadata about it, then you can make a better decision as to whether the user might want that picture at any given moment. And that's a job for AI. Yes?
Very different question. Now, if you're talking to lots of HCI people in here, what would you recommend they're going to do what you suggest? Be more open to AI techniques, to that more, you have to interpret the input, not just take it literally. So how should they learn about that? What should they do?
Yeah, I think so that's a good question. And I think that if you're a developer of HCI applications, then you can look at some of these things like the machine learning toolkit, the Weka. You can look at Intel's, if you want to use vision, for if you're working on images and you want to use vision somehow, you might look at the Intel's OpenCV. If you want to use the common sense knowledge base and common sense reasoning, then we have an open source toolkit to offer. So I think the situation is getting better in terms of being able to incorporate AI into HCI systems without needing to dig too deep into the algorithms and needing to dig too deep into the actual methods. So that stuff is getting much better packaged up. Okay, if you're not a developer, if you're an interaction designer, then I think just do consider the possibility of, could I make my system take speech recognition, or play around with some of the commercial speech recognition like Dragon or Max Speech, and just see, how well does it work? Under what kinds of situations does it work? And then think about using it as a component in your in your design. Too often, I think interaction designers just think, oh, those solutions, they're never going to work, so I won't think about them. Okay, George?
I'm wondering about failure modes of
Yep.
some of the AI systems. So, if I ask a person to perform some task and they make a mistake, they fail to do that task.
Right.
They're going to fail in a way that I understand.
Right.
Makes it feel more predictable.
Right.
Where typically, if the computer fails at some task, they're going to fail in some outlandish way.
Okay.
Speech recognition is a real obvious example.
Right, okay. So that's an excellent question. And so, we do have to deal with this problem that AI might fail, because it does. Okay. And I think what we need in AI is research on how to make better mistakes. So not everybody's too focused in trying to get the right answer or trying to get speech recognition that's accurate and stuff. Or, everybody wants to get the right answer. But I think we need to have research on making better mistakes. Okay, so and one of the things that we really like about our common sense knowledge is it makes really good mistakes. So we used it for let me just tell you a story. So we used it for predictive typing. So, because nobody can type on a cell phone. So we used it for predictive typing. So instead of doing the statistical predictive typing, where it looks for the common words in English or the words you've recently typed, the way most phones do, then we said, well, let's look for common sense knowledge. Okay, so if you type tennis and then a G, then it types tennis game. Okay, and we found that, so we thought, oh, this is going to be an easy Chi paper. All we'll do is just, test it A to B against the old predictive typing. Okay, and the result we got was that it was somewhat better, maybe 20% better or something like that, but the users thought it was spectacularly better. Okay. And we got such a discrepancy between what the users thought of it. The users thought it was so much better than it actually was. We decided to look into it. We eventually traced it to the fact that it was making better mistakes. So even the statistical prediction, when it makes mistakes, makes horrible mistakes. So you say, what a stupid machine, right? But even if I wasn't going to type tennis game there, I think, well, gee, that's a sensible thing to type. I wasn't going to type that, but it almost got it, or I'll forgive it this time. Maybe it'll do better next time. So learning to make good mistakes is a really good thing that I think we need both on the AI side and the HCI side. What makes good mistakes in HCI? And then I also think we need more research on, and this is also a subject of mine, is debugging. So it's okay, as long as we're not talking about nuclear power plants, it's okay to make a mistake the first time. But if you learn from your mistake, then people will, and the system gets better over time, people will have a lot more patience with it. What they really can't stand is the computer making a mistake, and then once it makes that mistake, it'll make the same mistake forever and ever. So I think if we have more research on debugging and more research on making better mistakes, it will mitigate some of these problems. And we need that for AI or no AI. We need that for HCI to make HCI better as well. Okay, last question maybe.
So along with that debugging, I often think as I drive along with my little GPS unit and I end up being at a place where there's supposed to be a ferry to cross and finding there's no bridge or ferry, that there'd be some nice way for people to, give some input back to the system.
Yep.
Have people started looking into things like that? Because, there's users out there who want to give feedback, but it's got to be quick because you're on the road.
Right. Yeah. So
just a button. Hey, you're wrong this time.
That's right.
So send back.
Yes, that's excellent. So you definitely. Present day GPSs don't do it. Okay, but future GPSs, of course, will be. They'll be connected over the web all the time. And if you ever get into any kind of trouble, you want one big red button on the GPS that says you're wrong, and then it have to try to fix it, improve it for the next user, So if we can get into that loop where a user correcting it can help fix it to the next user and it gets better over time, then again I think that'll go a very long way to making these systems more usable.
But how much research is being done sort of in that area?
Well, a fair bit on the AI side. And so the question is, we need to get HCI people involved so that the research that's done on the AI, because what AI people like to do, especially nowadays, is kind of break it off as a theoretical problem and then analyze it theoretically. And then they tend to make assumptions which aren't true in practice. And then so we need to get HCI people more involved to say, okay, what is it reason how much advice is it reasonable to give, or do I want to tell it it's wrong, or what do I do when I tell it it's wrong? But these things are investigated by people who are working on these things. There's what's called so there's two kinds of learning. There's what's called unsupervised learning, and there's supervised learning. Supervised learning is more where the user is guiding it and telling it how it did. Okay? All right, thank you very much.